So compound interest is a formula that uses an exponential equation for it. So we always use this as it's a nice one to talk about, not just necessarily like money growth, but lots of other things that grow this way too. So the amount of money that a principal P will grow after T years is at interest rate R in decimal form, compounded N times year, is given by the formula A equals P, and then we have parentheses 1 plus R over N to the power of N to the T. T is the variable. So it's kind of like our X in this case. But this is a pretty common formula for compound interest. So what it really is saying is that I'm going to have an initial amount. Then I have 1 to represent 100%. And because this is something that's supposed to increase, we're going to add a percentage to it. So this is going to be your rate as a percent, as a decimal. And then this is going to be the number of times we compound. So what we mean is how many times do I add this interest, this rate that I'm doing? So how many times am I going to calculate this increase? So like we could do like once a year, we just add that increase on, or we can add that increase on, 2 times a year, or we can add it on every month, we can add it on every day, we can add it on continuously. So this is how many times we add on the interest. So what we end up doing is we take that rate and we divide it by how many times we add the interest. Then we put it here again, because now in a year, if we were doing this monthly, that means that rate gets split over 12 months added onto it, which means it compounds 12 times, which means that I had to add it on 12 times. So then we would make that N also 12. So we're to have this one's to tell us that we're splitting it, the R 12 times, and to say that in a year, I added it on 12 times. Or if you're doing it, like every 4 or every 3 months, so quarterly, then you would divide the rate by 4, and then you would have this 4 to the T. Don't get too worried about this. So just to point out a few things. So if we talk about annually compounding, that means N is 1, means we just add it once a year. If it's semi-annually, it's twice a year. And I should have added this. But if we had quarterly, then N is going to be 4, because we do it 4 times a year. If we do compounding monthly, then N is 12. If daily, then we do 365. I believe banking does 360, but I can't quite remember. That was a long time since I did banking once. I remember it's a little strange. So for our first example, we are going to suppose that we have $100,000 and we're going to invest it at 6.5% interest rate. So this is going to be my R, and R is 0.065, because we're always going to use that rate as a decimal. This is my P, my principal. So this is what I initially started out with, is this much money, I'm investing it at this rate. And we are going to compound semi-annually, meaning that N is going to be 2. So we just want to write a function first. So the formula we had was this. So we're just going to fill in this formula. So what we have is that if we want a function for the amount, which is what my A represents, so it is the amount that we have grown in the investment after T years. Well, P was 100,000. And then we have 1 plus my rate of 0.065. We were compounding twice a year. So we have 2 here and then 2 to the T here. Okay, so just to kind of keep going with this, my 0.065 divided by 2 going to give me, just turns this into 1,001 plus 0.325 to the power of 2 to the t, which is then just 100,000 times 1.0325 2 to the t. So that is my formula for A. So for B, what we want is we want to figure out how much money is in the account after T years. So we're just going to take my formula for T is equal to 0, 2, 3. So we're going to have 2 times 0 here. And what this is just going to leave me with is just the amount of money that I originally put in the account. So it sat there, it's just like its first year, it hasn't grown at all. It's just going to stay at $100,000. T is 4 though. We're looking at 8 to the 4th. We're going to have $100,000, 1.0325, and then we're going to have 2 to the 4. So that's just 2 to the 8. 2, 3. Just make sure I have that in my calculator right. 2, 3. Raised to the power of 2 times 4. So I said 2, like that'd be 8. But this is going to say is after 4 years, I'm going to have $129,157. And if I round this, and 75 cents, or it's going to be in this account. So just do my last ones here. So I was asked for 8 years. So I'm asked for A to the 8 then. And I'm going to have 2 times 8, so that's just to the power of 16, really. In this case, I'm going to have $166,817.25 in my account. And then after 10 years, you plug that back in again. Oh, 100,000, 1.0325. We're gonna have 2 times 10, so it gets compound. So we are adding that interest rate 20 times. We're gonna get $198,583.79. So what we're seeing here is how much money do we keep gaining into this account? Okay, so this is the graph of our equation. I had to change for Desmos your T2 in X. And if we put in that amount of money, so we talked about at 0, how much we had after 4 years, 8 years, and then 10 years. So we can see those all graphed here. Okay, so oops. Scroll down just a little bit more. Kind of moved after I did that. Here we go. So as another example, so I'm using something from Michigan. So Michigan gets a lot of snow. So Michigan Department of Transportation spent, so this is what I looked up. This was like 2019 number, so I'm not sure if it's the same now, but they spent $210,000 on a new snowplow. Each year that snowplow is going to lose about 23% of its value. So the previous question, we were gaining value. Here we're losing value. So when you lose a rate, what we're going to do is we're not going to have like 1 plus that rate. It's going to be 1 minus that rate. So what we have here is that, that's annoying. What we have here is that my rate is going to be not 23%, but 0.23. So we have new spots. So I see each year it's losing value, meaning it's only compounding once a year. So we're compounding that loss once a year. And the initial amount we started with, our P, is at 21,000. So like I said, because we're losing a rate, we're going to subtract the rate that we're losing. So in this case, we're going to say instead of A, this is talking about value. We're going to call this value after time. The function for the value of the snowplow, that's my 2 there, is $210,000. That's my principal. Then we're going to have 1 minus my rate of 0.23. We're compounding only once, so we divide by 1, and then we have 1 t. So if we were to simplify this, this is just $21,000. And then this is just 1 minus 0.23, so that's 0.77. And then we just have to the t. So sometimes, like I said, we're not compounding. So this is just a formula showing you that really what's happening is that I'm only retaining 77% of my value each year. So for B, we're going to see the value of the snowplow after 2 years, 3 years, 5 years, and 10 years. Okay, so after 2 years, we have 210,000, or sorry, 210,000. And then this is multiplied by 0.77, and that is raised to the power of, in this case, 2. So we're going to lose a lot of value. So what we lose in about 2 years is actually about half that value. Actually, a lot more than half that value, because we're only, like I said, we're only retaining 70% of it each year. I think I just got bit by a bug here. If I do it here again, but this is 3 years later, I'm only going to have 95,871.93 percent of that, or $93 in value, is left in that snowplow. So part of the reason you do this is like if you were going to, it's taxing a loss. That kind of tells you like how much value did you lose. So you can always tax that loss on things. Since this is bought by the state, I don't know how that works exactly. If we do this, oops, not 2, 5 years. Then that snowplow after 5 years is only worth $56,842.47. After 10 years, so as you see, it loses a lot of value initially, but it starts to kind of steady a little bit. It's not losing quite as much. But after 10 years, I mean, it's still losing a fair amount of value. It's only going to be worth $15,386.03. Sorry about this for us, but it looks like this. Like I said, initially you're losing a lot of value. So that's how much we lost from the first year to the second year. And then this is my third year here. This is the fifth year here. This is the 10th year. After the 10th year, I mean, it's going to lose some value, but it's not losing as much as steadily. All right, so for your problem for your worksheet is suppose that we have 200,000 is invested at 2.3 interest. We want you to find a function for the amount to which the investment grows after T years if we compound annually, and then find how much money is in the account after 5 years. So give me the formula, then tell me how much is left after 5 years. And then you're going to repeat this for compounding monthly and then compounding daily. Okay. So what we have here is we had a principal of 20,000 or 200,000. My interest rate, my R, is going to be 0.023 because that is that interest rate as a percent. So because we're doing annually at first, this means that N is going to be 1. So my formula is A to the T is that principal of 200,000. And then we're going to have 1 plus my rate of 0.023 over 1. And then it's just going to be 1 times X up here. So, or 1 times T up here. So this one's going to be easy. It's just 1.023 to the T. So if I want to figure out how much is in there after 5 years, we have 200,000. Okay, make sure I have that number right in my calculator. Be careful with these huge amounts that you have enough zeros when you do this. And we're doing this to the power of 5 because we want the value after 5 years. So after 5 years, what we're going to see here is that your investment is going to have grown from 200,000 to $224,082.62. Okay, so let's do this with B now. So with B, we're compounding monthly, so N is 12. So we do A to the T, we're doing the $200,000. And then we have 1 plus 0.023, but this is divided by 12, and this is 12 to the T now. So we want to get that rate. So what you're going to get is that 0.023 divided by 12. Be quite a number, so we're going to do some rounding here, but it's going to be 1 plus 0.12, we'll say 192. Like I said, I'm doing a little rounding, 12 to the T. So A to the T is going to be 200,000, 1.00192. That's what we're growing by each time that we compound. 12 to the T. Okay, so if we went A to the 5th, we're going to change T to a 2, 1, 2, 3. We're going to have the exponent's going to be 12 times 5, so it's going to be 60. And what we get here is that your investment is now going to have grown to 224,394.78. So what you see is that I got about $300 more by just compounding monthly. So when you change how much you compound by, it will change your final answer. And then for my last one, C. Now C, okay, this is all B. C here is going to be compounding daily. So then N is going to be 365. So A to the T is going to be your 200,000. 1 plus 0.023 divided by 365, and then to the power of 365t. So this one, I'm actually not going to try to give you this decimal version here because the decimal is really, really, really big. So I'm going to leave it like this. So if we put it in your calculator, A to the 5th, so 5 years later, three, 365 times 5. So make sure you put these exponent, make sure you put all these, there we go, these parentheses here. So we want parentheses around that 0.023 divided by 365. Put that there. Then you want to have the ones to include the one. Then make sure you have ones around the exponent, just to make sure that this works out correctly. $65. Oops. In my case, it didn't because I messed it up. So it kind of depends on what calculator you're using, what parentheses you need, but having all of these will not hurt you. But if you did this, what we ended up with is at this time, okay, because there was a little bit of rounding here. So if we had left this as, say, this formula instead, what you would have gotten is, because we did that rounding, it moved everything up quite a bit. Like I said, if I left my formula like this instead of trying to get my decimal here and rounding, what we would have had is that for compounding monthly, you would have had $224,349.99. If you compound daily, you get $224,373.87. So as we increase the times we compound, what you see is that the amount of money in your account should become larger and larger.